So we're in lockdown, and I've got a few projects I want to do. One project I want to do is a tricopter, but it's a tricopter with a difference. This is a kind of conventional tricopter, and obviously it's got 3 motors, and one of the motors will be able to pivot to control the yaw. And you need that because only 2 motors go in one direction and the other is going the opposite direction, but that's in imbalance, and so this would spiral out of control if you did not have the ability to adjust the angle on one of them. It's called the yaw, and I mean in a helicopter it would be the tail rotor. So what I want to try and do is make a tricopter out of foam. So the propellers are in ductwork, something like this, and then I want the yaw to be controlled by rudders mounted underneath here and driven by a servo. So that's the idea, but the first thing we're going to do is make these out of foam. So I got given this foam board a while back, and it's been behind my shed for ages, so it's all dirty. And I'm going to use this for the duct for the propellers. First thing I have to do is this actually comes covered in this basically it's fiberglass tissue, so I need to peel that off. If you're lucky, you can get it off in good strips. Otherwise you spend quite a while picking off the corners, like this one. So I'm going to do that, and then I'm going to mark out here and roughly cut out a circle. So I've roughed out my circle, and now what I've got to do is find a way of mounting this in my lathe. So what I've got is a face plate, which I've put a piece of 3/8 plywood on, and then I've got these 8 screws here, around there. And all I'm going to do is approximately get that in the middle, tighten the screws up, and then support the whole thing in a lathe using the tailstock. And then try and get this round. Okay, so I've got that mounted in my lathe. It's about the biggest diameter I can get in my lathe. You can see I've mounted on the faceplate here, and on the other side I'm supporting it with a rotating centre on this piece of plywood here. The screws alone will not stop this flying off if you try to turn it down. Best method I've found is to use a Dremel with a sanding drum in it. Do not underestimate how much dust this will create. I would seriously advise you wear a dust mask. Do not underestimate how much mess this stuff makes, but at least it's quick and easy to do. So hopefully you can see this. I've roughed out the inside while keeping the tailstock in place. Now I've got it nearly to the right size. I'm going to take the tailstock back, and then I'm going to have to remove this middle bit and just finish off this by hand using sandpaper. So I got this to approximately the right diameter. Then I find it easy just to use sandpaper to make sure the propeller fits in nicely. And then I'm just going to make a little bit of a bell on here just to help the air go in. So I'm happy with the shape and the diameter, so the last thing to do is to separate this from the backboard. Okay, that didn't work. So I've got a little bit of tidying up to do, but it's fairly lightweight. It's fairly easy to do, just pick it off. I don't think I'll need to go that deep anyway. As you can see, I've done quite well. I've got the 3 ducts made, and I've also joined them together with a little piece in the middle. But then the next stage is how to mount the motors. And to help me with this, I've put the model onto my table, and I've then drawn around it. And I had various options available to me, including plastic mounts, these aluminium mounts that clamp onto 12mm carbon tube. But I decided to go with a triangular method. So we've cut out some fiberglass mounts. There'll be 2 down here and 1 there, and then they will join each other in a nice triangle, and the motors will be mounted on these plates. So that's what I'm going to do now. I'm going to mount all the hardware and cut the tubes down, and then try to work out how I can feed the tubes into the ductwork. So I've progressed again this morning and managed to make the framework up, the triangle of motor mounts, and you can see the 2 clamps here and the 1 clamp here. The motors are installed with the propellers, so I could line everything up, and then I've glued the whole lot in. Decided to cut slots from this end going down because it was easier than cutting holes in the side of the ductwork, and they're about right position in the ductwork anyway. Where I've glued these, I've just gone over the tubes with a bit of sandpaper to make a bit of a better key. They're not perfect, but once you start the propellers up, that will cut nicely into the foam anyway. So now the next part is to try and do the rudders. So I've decided how I'm going to do the rudder. What I've got is a piece of piano wire going across here, and then I've got a piece of tin strip soldered to a connection block. That's one of the connectors out of one of these terminal strips. And then what I'm going to do is I've got 16th plywood, and that's going to get epoxy to the back of that. And then what I can do is I'll sandwich that in between another sheet, so that will give a good shape. That'll leave the screws still exposed, so I can undo that and adjust it, and if necessary I can take it off and change it. I'm going to try and get away with only doing 1 rudder for the time being. The piano wire goes all the way across the centre, and there's an arm here so it can be controlled by a servo. So that's the rudder all finished, and as I said, it's connected to this push rod that goes all the way through here, and there's a little operating arm here. This morning I've then managed to get all the speed controllers in. They're mounted the other way up. Let me just turn it over. So you can see the speed controller there. There's one on each arm. And then I've also done the power wiring. So the last task is to hook up this rod to a servo. And I thought long and hard about how to do this and had a rummage through the drawer of bits and came across this little thing. I don't know what you'd call it. So this is what I've come up with. I've got this little push rod connector that's screwed onto the servo horn, and this is a smaller size servo which will nicely fit in the middle section here and push onto the push rod. So I'll just do that and then I can demonstrate that. So that's the servo in place, and you can see it's linked to the push rod. And I've just used this 3/8 piece of plywood to go across the two pieces here. I'll put some long screws in there going into the foam. That should hold that in place. I can't glue it in place because obviously I won't be able to get the servo out afterwards. And that obviously then goes all the way across to the rudder. So just see. So I've just got to screw that into place and then get the flight control board on, and then it'll be complete. Okay, so everything's finished and the KK board is wired up. I've given it a couple of test flights and it hasn't ended well. And it would appear that I have a yaw control problem. These ducts really are not very strong, and every time I've come down it's dug in quite badly into the foam, and on the last time it's actually cracked this one all the way down here, starting there all the way through. So that's now gluing. I figure the main problem is the rudder. Because it's on piano wire, you're able to twist the whole wire without the rudder moving. So as soon as the flow of air goes past the rudder, it's straightening it and twisting the wire instead. So what I'm going to do is I'm going to change that piano wire for a carbon fibre rod, which thankfully still goes through this terminal block here. So I'll just be able to take this off, replace it, and then I'll have to sort out this end. And then I can give it another go. Okay, so I'm having to narrate this as the volume in the shed with the fans running was far too loud. So as you can see, I've tied this to the roof of my shed just to try and understand what is going on with this rudder. So the only way you can actually do this if the model is well trimmed, that's to say the string, as you can see it in the middle of the screen, is dead plumb, and the model sits level in both X and Y. This is a useful thing to do with all drones when you're first setting them up. It allows you to balance the model so it's neutral. If you've got a battery, for example, offset, then you'll find where the weight is, the fan that is nearest to the extra weight will have to work harder. So I'm just trying to work out what this rudder is doing. You can see here that I'm actually moving the rudder, and I can stop the model spinning. But in this particular direction, it's really struggling to send the motor, let's say clockwise, looking down from the top. It'll go easily the other way, but that's because there's two motors working in that advantage. You can also see I've lengthened the rudder by taping on an extra sheet of balsa wood. I think the only solution here will be to basically duct or put rudders across the whole duct, so you're vectoring the whole duct. I mean, in principle you can actually see it does work, and it is able to stop itself spinning, and you can see the rudder controlling the spin. I'm just going to demonstrate what it actually does by bringing the rudder towards the camera. And actually I'm struggling to do this because it's trying to resist me turning the model, which is what it should do. Here you can see I'm forcing it clockwise and anti-clockwise, and the rudder itself is trying to resist that movement. So it spins very nicely that way. However, put the rudder fully the other way and it slows down eventually, and with a little bit more power it starts to go the other way. So potentially I either need to make that rudder bigger, vector the whole duct, or maybe even put rudders in the other two ducts. So there's a lot more work to be done on this rudder, and I think that's for another video. Thanks for watching.